Now we can look at how we can solve a basic inequality. So suppose for a moment that we have an inequality, then we can add the same quantity to both sides and the inequality is preserved. So if A is less than B, if I add C to both sides, then we're okay. This is much like what we saw with equations. Likewise, if we have the desire to subtract the same quantity from both sides, there's no problem, the inequality is still preserved. So, if we have x minus 5 is less than or equal to negative 2, and we want to solve that, well, we can just isolate x by adding 5. So, our inequality is preserved. X is less than or equal to 3. So, in set notation, we would write all the x's, the set of all x's, where x is less than or equal to 3. If we're going to write it in interval notation, let's do the graph first. So, here's 3. We want to be where the x's, we want to shade where the x's are. So, x's are less than or equal to 3. So we will shade to the left. And now, since there's an equal bar, we will include the 3. So in interval notation, as we read this left to right, we're shading toward negative infinity, and then we get to 3. So negative infinity to 3. Remember, we always use a parenthesis with infinity and with negative infinity. And since 3 is included, we use a bracket. If we want to multiply both sides or divide both sides of an inequality, then we can do that too. There is just one issue that we have to deal with. If we're multiplying or dividing by a positive number, all is good. Our inequality is preserved. However, if we multiply or divide both sides of an inequality by a negative, notice the inequality switches signs. So C is negative. If I multiply both sides, the inequality switches. So if A is less than B and I divide by a negative number, I now have to switch the direction of the inequality. Let's just show you why that would be. If we have 4 is less than 12. If we divide both sides by negative 2, we get negative 2, we get negative 6. Notice which one's bigger. Negative 2 is bigger than negative 6. So the only way to preserve the inequality is to switch the direction when we divide by a negative. So this is the only thing that you really have to watch out for in this section. If you multiply or divide by a negative number, you have to switch the direction of the inequality. So here, we have 2x is less than or equal to 6. Let's divide both sides by 2. So this yields x is less than or equal to 3. So where is x going to be? It's going to be to the left of 3, and it can include it. So in set notation, we would have all x's where x is less than or equal to 3. In interval notation, we'd have negative infinity up till 3, and we include it. So to solve an inequality like the one we face here, we do it much the same way that we would if we were to solve an equation. So we'll distribute the negative, simplifying both sides first. So we have 7 minus 2x plus 5 is less than or equal to 8. Now let's collect like terms on the left-hand side. We have negative 2x plus 12 is less than or equal to 8. Now we can subtract 12, and this gives us negative 2x is less than or equal to negative 4. Now we're going to divide both sides by negative 2. So we have x, we have 2, but we divided by a negative. So we should switch the direction of the inequality. So x is going to be larger than or equal to 2. So our set notation would be the set of all x's where x is larger than or equal to 2. Now if we find 2 on our number line, we would want to shade to the right, and we want to include the 2. So interval notation would be 2 to infinity. Bracket the 2, infinity always gets a parenthesis. Now we have 3 inequalities. So let's clear our fractions first. To clear our fractions, let's multiply each of these 3 expressions by 2. So we have negative 3 halves. We're going to multiply by positive 2. So you'll notice that if I'm multiplying by a positive, the inequality stays. 4x minus 1 over 2 is going to get multiplied by 2. And then 7, likewise, is going to get multiplied by 2. So we get negative 3 is less than, and the 2's cancel there as well, 4x minus 1. Oh, I made a mistake. This should be less than or equal to 7. So this should be less than or equal to 14. Now, let's add 1. And this gives us negative 2 is less than 4x is less than or equal to 15. Now we're going to divide everything by 4. And dividing by 4 is okay. We're not dividing by a negative, so we do not have to switch the direction of the inequality. So we have negative 2 divided by 4 is negative 1/2. Then we have is less than x is less than or equal to 15/4. So our set notation would be the set of all x's where, and then we would simply write that inequality. So let's find these on our number line. Negative 1/2, we don't include it, and 15/4 is going to be 3 3/4, and we do include that. And so our interval notation would be negative 1/2, comma, 15/4, with a parenthesis at negative 1/2 and a bracket at 15/4.